All right, let's take a look at using this remainder theorem and factor theorem to factor polynomial functions. But first, on the first two, we're just using the remainder theorem to evaluate this function. You could plug in 2 for x and do that arithmetic, or you could do synthetic division. Let's check and see if this is in standard form. 7, 6, 5, 4, 3. There is no 2 again, similar to the first problem on the last homework. So I'll need a 0x squared there. So I've got a 3, a negative 10, a 2, an 18, a negative 4. I have to put in a 0 as a placeholder, a 2, and a negative 10. First number always comes straight down. If you're below the line, you get multiplied by the number in the box. Then you add. You get multiplied by the number in the box. And you add. And it just, that pattern just continues. So f evaluated at 2 is equal to 58, telling us that this graph passes through the point 2, 58. All right, so let's do the next one. Same directions. Let's check, is it in standard form? That's always our first step. 6, 5, 4, 3, 2, 1, constant. So this time I have all terms. I don't have to have a 0 anywhere. 1, 9, 6, negative 12, 35, 25, and negative 5. First number always comes straight down. If you're below the line, you get multiplied by the number in the box. So this function, when evaluated at negative 8, if you chose to substitute in negative 8 for x and do all of this arithmetic, you should get the same answer. If we get different answers, then there's a mistake somewhere, either in our synthetic division or in doing this arithmetic and plugging it into the calculator, probably. Our directions have changed now. We want to factor f of x completely, and then find all of the zeros. They give us 1 0. We know for a third degree there's at most 3, so we might have 2 more zeros to find. So let's again start out with synthetic division. Is this in standard form? 3, 2, 1 in a constant term. There's no greatest common factor there. If there is a greatest common factor, you need to factor it out. So with the remainder of 0, this verifies that f at negative 6 equals 0, which means the graph is passing through the point negative 6, 0, which that's an x-intercept. That's a 0 of the function. So now I can factor this f of x. This negative 6 in factored form will be x plus 6. And the 1, 2, negative 3 is a 1x squared plus a 2x minus a 3. To find the zeros, we set the output of the function, the y-coordinate, equal to 0, and we solve this equation. We factor this guy, this trinomial, using just our normal factoring abilities. X method if you prefer, or since the leading coefficient is 1, 2 numbers that multiply together to give you negative 3, but add together to give you positive 2. It's pretty straightforward. So the zeros of this function are -6, which we expected that one. They gave us that one. And -3 and +1. We found 3. You can have at most 3. Here are the zeros for this function. This time, the information that's given to us is a little bit different. They give us 2 x-intercepts. They give us 2 zeros of this function. F evaluated at 5 is 0, but also F evaluated at 3 is 0. So we're going to use both of these information to help us find all of the zeros. Since it's of degree 4, there's likely to be no more than 2 more zeros of this function. So it doesn't matter which one I start with, whether I start with 5 or 3. I'll start with 3 just to be different. To do my synthetic division. Let's look and see if this has any greatest common factors. No, there's no number that divides all of these. And is it in standard form? 4, 3, 2, 1, 0. Yes, it's in standard form. So I've got 2, -5, -53, 125, 75. So I'm expecting a 0 here if everything here is stated correctly and if I do everything here correctly. All right, so we know what this does for us. We know that f of x can now be written as x minus 3, because in factored form you had to change the sign. And now, since this was of degree 4, when we did our synthetic division, this is now of degree 3. So I have 2x cubed plus 1x squared minus 50x minus 25. Well, I know that this polynomial, I can factor it, and I know that 5 is going to be a 0 because I haven't used it yet. So let's come in with this 5. Is there any, this is in standard form with no missing 3, 2, 1 constant term with no missing terms. So I've got 2, 1, -50, -25. And I'm expecting a 0 right here, and if I don't get it, then something's wrong somewhere. So I've got 2, 10, 11, 55, 5, 25. So let's return to this f of x, and we factored it before using the x minus 3, and now we have factored it with using the x minus 5, the fact that 5 is a 0, and this was of degree 3 when we did our synthetic division. We lost a degree, and now this is of degree 2. So now you can do your x method on this last one here. And what you should get, 2x times x plus 1 plus 5. Because I have 2x squared, 10x plus 1x is 11x plus 5. So that means that I can now find 4 zeros for this function. I can find 3, they gave me that one. I can find 5, they gave me that one. But now I know that -1/2, if I subtract 1 and divide by 2, and if I subtract 5, I have now found all of the zeros. So here they're giving me 2 of the factors. So I can use that to factor this completely. If I look here, I see no common factor. 4, 3, 2, 1 constant term. I see it's in standard form. The x-intercept, the 0 of the function for x plus 4 is a negative 4. And I can now peel off 3, negative 1, negative 50, 16, 32. The first number always comes straight down. And 52, 2, negative 8, 8, negative 32, and I got the 0 that I was expecting. So that means that this f of x, that x plus 4 is a factor, and that I have 3x cubed minus 13x squared plus 2x plus 8, and now I can work on factoring this, knowing that I haven't used that x minus 4 is a factor yet. So 4 minus 4 gives me 0, so this time I do synthetic division with a 4. I peel off these numbers, that's in standard form, 3, 2, 1 of the constant term. I'm expecting a 0 here. Hopefully I get it. And I do. So this original f of x, I knew from the information given here that x plus 4 and x minus 4 were going to be factors. They told me that. But I didn't know, in order to multiply this all together to get this, that the rest of it would be 3x squared minus x minus 2. That's what the synthetic division helped me to get. And now, when I get to a trinomial of degree 2, I can use the quadratic formula or factor it. If I have plus 2 and minus 1. Now, if you can't do this, just do the x method over here on the side, and that's what you should get. Alright, so I've got 0, x plus 4. Oh, I already wrote that. Why am I writing it again? Negative 4, positive 4, but I knew that from the information given. But what I didn't know at that time, that subtract 2 and divide by 3, that negative 2/3 and positive 1, and since this is of degree 4 and we found 4 zeros, that's as much as there can be. You can't have more zeros than the degree of the polynomial. This time x minus 3 is a factor with a multiplicity of 2. Let's look and see there's no greatest common factor to these. There's no number that divides all the terms. 4, 3, 2, 1, 0. This is all in standard form. If x minus 3 is a factor, then 3 is a 0. When it's in factored form, you take the opposite. So I've got 2, negative 5, negative 18, 27, and 54. I'm expecting a 0 here. Let's see if I get it. I don't want to make a silly mistake. So I've got negative 18 and negative 54. So I know then that I could write this as x minus 3, 2x cubed plus x squared minus 15x minus 18. And I know that this guy, I can use synthetic division, and since the multiplicity was 2, I can do this again with the same number here, but only with this reduced polynomial degree. And I should get a 0 again. Let's see if I do. And I do. So I know that this f of x factors to x minus 3 with a multiplicity of 2. And now I know that this 276 represents 2x squared plus 7x plus 6. Set this equal to 0 to find the remaining zeros. Use the x method if you need to factor this. I need 2 and 3, so I'll need a 2 here to get 4, and a 3 here, and 4 plus 3 is 7. I've got 2x squared plus 4x plus 3x, which is 7x. So I can now write all of my zeros. I have a 0 at x equals 3 that has a multiplicity of 2. Remember, it's doing a touch and turn if we look at the graph. And here, these guys, it's crossing the graph, not doing touch and turns. So even though the degree was 4, this multiplicity here accounted for 2 of them. So 2 plus 1 plus 1, hey, 4. So we have found all of the zeros. There can't be any more. This time we have negative 4 being a 0 with a multiplicity of 3. Let's check and see, is this, I don't see any greatest common factor. Is it in standard form? 5, 4, 3, 2, 1, 0. Yes, and I don't see any missing terms. So I can do this. I'm expecting this to be 0 here. Let's go ahead and double check that. Yeah, okay, and multiply it by negative 4. Subtract 432. Multiply it by negative 4. And I get 576, so I get a 0 there. So this f of x, I can write it in factored form as x plus 4. Since this was of degree 5, this now starts with degree 4. X to the 4th, 8x cubed, 7x squared, 72x minus this constant term. And I know that I can use this negative 4 again because it has a multiplicity of 3. So again, I know that now this time x plus 4 is a factor of this. So we can divide I'm expecting a 0 here. Alright, so this f of x, I now have another factor of x plus 4, so I can write it as x plus 4 squared. This was 5, now it's 4, this one's 3. I'm referring to the degrees. So let's, it says of multiplicity 3, so I can do this one more time, only on this x to the third. So if I have negative 4, and I have 1, 4, negative 9, negative 36, I've got 1, negative 4, 0, 0, negative 9, 36, that's 0. So we can now write this in factored form. We factored it completely because we have the 3 factors here, this multiplicity 3, and now I've got x squared. The 0 is 0 x's, which I don't have to put 0x because 0 times x, then minus 9. And I can see that this is a difference of perfect squares, and I can factor this to x plus 3 cubed, x plus 4 cubed, x plus 3, x minus 3, and then I have zeros of negative 4 with a multiplicity of 3, and I have negative 3 and positive 3. So since this has multiplicity 3, and these have multiplicity 1, the 3 plus 1 plus 1, hey, that's 5. So I have, there can be no more. I have found all of the zeros, the x-intercepts for this. Alright, so let's take a look at this one. We have x minus 1 being a factor of multiplicity 3, and x plus 2 is a multiplicity of 2. Okay, so we can do these in any order. Let's just start with the 1, and I've got 1, or let's see if this is in standard form. I see that there's no number that divides all of these, so there's no greatest common factor. 7, 6, 5, 4, 3, 2, 1, constant term. I'm expecting a 0 here if it's true that 1 is a factor. I pull this down. Excuse me, that 1 is a 0. X minus 1 is a factor. Multiply, add, multiply. Add, multiply, or add and multiply. I'll just shut up and do it. So I have that. So now, if you want, I can just keep, since this is going to be 1x to the 6th, 8x to the 5th, 18x to the 4th, and I've got a multiplicity of 3, I'm going to go ahead and do 1 here again, and I'm expecting a 0. Just saves you a little bit of writing. Now, I think no. I thought I made a mistake there for a second, but no, I didn't. Okay. So since it's a multiplicity 3, I can do it again. And again, I'm expecting a 0 right here. All right, so I've used the three factors of 1 now. I have x plus 2 with a multiplicity of 2. X plus 2 has a 0, a negative 2. I'm expecting a 0 here. I get a 0 there. I can do it again with negative 2 because it said multiplicity 2. So I'm expecting a 0 over here. And I get it. So now, well, how do we factor this all together now? Well, we have f of x. We had these 3 1s right there. In factored form, x minus 1. There's 3 of them, so that's of degree 3. We've got x plus 2. Right here, these two. And this is x squared plus 6x plus 9. And that factors to x plus 3 squared. So we're finished. They gave us most of it. They gave us that x equals 1 was a 0 of multiplicity 3, that x equals negative 2 of multiplicity 2, but they didn't give us this negative 3 of a multiplicity 2. 3 plus 2 is 5, plus 2 is 7. The original thing was x to the 7th. We have found all of the degrees. Now, is that the last one? Yeah. Hope that helps. Sorry for so long. Talk to you later.